Good morning, everyone. We're going to go ahead and start the next section, section 3. And this is kind of, I think, hopefully a pretty simple section that's going to bring together a few ideas that we've already talked about, including the Pythagorean theorem, to establish a couple of new important identities. We'll talk a lot more about identities in chapter 12, but this is just an introduction to some important ones. Identities are just mathematical statements or equations that are true for every single value of the variable. So let's just see if we can derive a couple real quick. We're going to start with a really basic idea here. If we have an angle of rotation, and it could be in any of the four quadrants, this will be true for any angle of rotation, we know that it intersects the unit circle at a given point, and the x-coordinate is given by cosine of theta, and the y-coordinate is given by sine of theta. If we were then to create a right triangle here, we know then that the horizontal leg corresponds to the x-coordinate of this point up here, so that'd be cosine of theta, and the vertical leg is equal to the y-coordinates, so that would be sine of theta. And we didn't say it to start, but hopefully it was clear that this is the unit circle. So let's make that clear. This is the unit circle we're talking about. So knowing it's the unit circle, then we know right away that the radius of the unit circle is 1, and so this hypotenuse right here is 1. And we've looked at this triangle a bunch already, but we just want to make a statement here. Based on the Pythagorean theorem, we know the Pythagorean theorem says that a squared plus b squared equals c squared. That's true for any right triangle that ever happened, where the sum of the squares of the legs is equal to the square of the hypotenuse. So here we know that the lengths of the legs are cosine and sine. So using the Pythagorean theorem, we'd be able to say simply that sine theta squared plus cosine theta squared, that's the length of the vertical leg and the horizontal leg, is equal to the square of the hypotenuse. The hypotenuse is 1, so we would just have 1 squared. And here is our first identity. I'm going to simplify it a little bit. When we have a sine function or any trig function where the function value is being squared like this, we have a little shorthand notation where we will just say that the function value is getting squared. So we would call it sine squared of theta. So really important for us to note this, make sure we understand this. Sine squared theta is equal to sine of theta squared. This is a notational thing that we have to pay close attention to. So that would mean that we have sine squared theta. Also we have cosine squared theta. And of course 1 squared is 1. And then here is our first most important trig identity, putting lots of stars around this. As you go forward, this is probably the single most important trig identity to remember, to have memorized. There are plenty more that we're going to learn that I'm not going to make you memorize, but this is one where you definitely need to have this memorized. But hopefully it's really simple and intuitive from the Pythagorean theorem and from right triangle and the unit circle. So we have this identity that's always true. It's useful in a few different situations. We'll look at an example in a minute or two, looking at how we can use this identity. But what we want to do now is look at some of the alternate forms of this identity that come into play. So one way we can get an alternate form is if we simply subtract sine squared and cosine squared. So this comes up sometimes on some problems where we'll end up seeing, maybe we'll just get sine squared and we'll want it to be in terms of cosine. That'll make more sense when we get to those kinds of problems. But so here's one alternate form. I'm not going to put as many stars on it, but this is one to recognize. This one up here is the primary one to memorize. But all these alternate forms are useful in different situations, and we'll kind of see when they're useful as we go throughout the course. Alternately, I could have subtracted sine squared from both sides, and that would have given me the following: cosine squared equals 1 minus sine squared. Again, these identities will come up occasionally. This top one is the primary one that we definitely need to have memorized. But these alternate forms will be helpful in some situations. And there's two other alternate forms that we want to talk about real quick. So I'm just going to call them alternate forms. These two are alternate forms up here already. But one alternate form is going to come if we divide everything by sine squared. So remember, as long as we perform the same operation to every term in an equation, we can always do that. So if I divide everything by sine squared, what I want to see now, so that's going to give me a new form here. We have sine squared divided by sine squared is just 1. Cosine squared divided by sine squared, well, I'll remind you that tangent theta is sine over cosine. Cotangent theta is its reciprocal, cosine over sine. Well, these would hold up if you squared them as well. So cotangent squared would be equal to cosine squared sine squared, and tangent squared would be equal to sine squared over cosine squared. Well, if we look right here, I have cosine squared over sine squared, and I can see that that is equal to cotangent squared. So I have 1 plus cotangent squared equals, we'll also remember our reciprocal relationships. Cosecant is the reciprocal of sine. So when I have 1 over sine squared, that is equal to cosecant squared. So here is another alternate form of our Pythagorean identity. Again, this one up here at the top, that is our primary Pythagorean identity, but there are a few different ways of rewriting it that can be useful in certain situations. There's one more alternate form we want to look at real quick. That last one comes if we take the original, sine squared plus cosine squared equals 1. And if instead of dividing by sine squared, this time we'll divide by cosine squared all the way across the equation, and we'll see something very similar happen. So we have sine squared over cosine squared. Hopefully I recognize that right there. Sine squared over cosine squared is tangent squared. Cosine over cosine squared over cosine squared, that's just 1. Anything over itself is 1. And then lastly, our other reciprocal relationship was that secant is the reciprocal of cosine. So where I see 1 over cosine squared, this would be equal to secant squared. And so I have this new alternate form of the Pythagorean identity. So we really have right here 5 different forms of the same identity. Okay, and really only this top one is one that you need to definitely memorize. The others are all helpful if you can remember them. These ones come in handy a little bit more often in this course, but on occasion these ones down here will happen. They'll happen tonight on the homework, so we're going to look at an example or two where we use that. But really, it's all based on this top single identity of sine squared plus cosine squared equals 1, which comes very easily and naturally out of the unit circle and the Pythagorean theorem. Right, so in our next video, we're going to look at, okay, how can I use these identities to help me find trig functions? That's coming up next.